Statistics would be in the mathematical realm. Sometimes we like to talk about because it doesn't give exact answers a lot of times, so I'm frustrated about it. A, B times C, D. The question is, how do we multiply vectors? We added them, no big deal. We subtracted them, no big deal. Well, what about multiplying them? Exactly. A times C plus B times D. So you are right that we take the two A values, or X values, and multiply them. We take the two Y values and multiply them, but then we add them together. You do not come up with a new vector. You come up with a numerical value. So in example 1, it says find the product of the vectors and the angle between them. We're not going to focus on the angle right now. We're just going to focus on the product. U times V. I'm not going to do -1, 2. I'm going to do -1, 4, because sometimes people get confused. I use the number 2 twice. So this will help with any confusion that people have. So as I do U times V, I get what? What do I do? -1 times 2 plus 3 times 4. Yep, so -2 plus 12 is just 10. So 10 is the dot product. For the next one, you do it on your own. Go. It is. I've got -1. All good? Okay, not a tough part of the test, is it? Okay, so let's move to the angle form between two vectors. Suppose it is not. Suppose that you have a vector here and a vector here, and you're looking for the angle between them, theta. Angle between the two vectors. The formula involves the trig function cosine. Cosine of theta is equal to, and what we do is we do the dot product, U times V, that's what goes on top. And what goes on bottom is the magnitude of U times the magnitude of V. Nope. Not bad at all. Look at this one. It says find the angle between these two vectors. So I set up the cosine of theta is equal to what goes on top. 10 goes on top because that's the dot product. On the bottom, I have the magnitude. And the magnitude, do you remember how we find the magnitude of a vector? Square root of a squared plus b squared. So -1 squared is 1, and 4 squared is, so we get the square root of 17. Times the square root of, and then we do the magnitude of 2, 3. Square root of 13. So I noticed that for some people it's more helpful if they multiply the 17 and the 13 together. So people were making mistakes with this before. 17 times 13 is a grand total of 221. So you have the cosine of theta is equal to 10 over the square root of 221. If I'm finding the angle, what do I press on my calculator? Yep, second cosine, or cosine inverse of 10 divided by the root of 221. You can, but sometimes people don't put it in the correct order of operation, and it makes a mistake. So, I don't think that will give you 47. There you go. So 47 point. Sure. 47 point though what? Somebody? 7.3? So as I put in my calculator and I go cosine inverse of 10 divided by, and then sometimes people just put the square root. You have to put both square roots underneath there. So you need a set of parentheses. The square root of 17, and then you need the square root of 13. So that set of parentheses right here includes both of those pieces in the denominator. If you don't do that, you're going to not get the right answer. Okay. what I would like you to do is try to find the angle form between those two vectors on your own right now. Go ahead. All right. Here we have the cosine of theta is equal to -1 in the top, and in the bottom, the magnitude of this vector is the root of 2, and the magnitude of this vector is 5. Or, some people put it as the root of 25, because they raise -1 over the root of 50. And that way they're able to put just one root into their denominator. So cosine inverse of -1 divided by the root of 50. Oh my goodness, I notice that it is negative. This is the one time that you plug a negative in, because cosine understands the difference between positive and negative. Is cosine positive or negative in the first quadrant? So that's where you get acute angles. How about the second quadrant? It's negative, so we're obtuse, right? So we know we're going to get an angle somewhere between 90 and 180 degrees. I press enter, and sure enough, I have 98.13 degrees. Aaron was sitting in radians. We totally get it. Classic mistake. Classic mistake. Orthogonal vectors. What are orthogonal vectors? Yeah. We have an obtuse angle. And we knew it was going to be obtuse because we got a negative value. Cosine is negative in the second quadrant. Does that make sense? Orthogonal, maybe you remember from geometry, the orthocenter, or orthocenter, circumcenter, incenter. No? Do you remember those words? I'm getting a very blank stare. You don't remember any of those, like, center points of a triangle? You don't remember those? Okay. All right. All right, very good, very good. So orthogonal happens to be, it was used with the altitude because those are 90 degrees. So orthogonal means perpendicular. Okay. Now let's think about perpendicular. Perpendicular is 90 degrees. What is the value of cosine at 90 degrees? It is 0. So when this thing is equal to 0, the angle will be 90. So let's think about it. When is a fraction equal to 0? Is a fraction equal to 0 when the top is 0 or when the bottom is 0? The top. So when the top is 0, or simply when the dot product, u times v, is equal to 0, we know that those vectors are in fact perpendicular. They are orthogonal. So we should be able to look at a couple sets of vectors and say, are they orthogonal or are they not? So a times b is equal to -2 plus 2, which is 0. So yes, they are orthogonal. Try the next one on your own. Just thinking right now how I break into Miss Richter that she never taught you guys orthocenter or incenter or circumcenter. You know, that was your hybrid year, wasn't it? For some of you guys. So some of you guys had geometry last year. Others of you had geometry the previous year, which was the hybrid year. So it's very possible that she chose to leave that out. Possible. Don't you feel robbed of that? Which is it? Okay, all right. You learned that being in school is important. Yeah. What is it? It should know like orthocenter, like 90 degrees, orthogonal 90 degrees. So what about orthodontist? Yeah, I guess I don't know. All right, so here you have 5 times -6 is -30 plus another -30. So is it orthogonal? No, -60. So no, not orthogonal. Did I catch you there? You saw the 230s, you thought they cross off. That was the goal. Let's try and trick you. All right, now we want to talk about work. We like to get work done, right? All right, so I would like to break down this door. Think I can do it? Oh, hear the hinges? Like, I'm pretty strong. You hear that? All right. We're going to press. I pressed 285 in high school. Lactic acid is building up in my arms. I am tired. I do have lactic acid building up in my body. I have used calories in order to exert that force. How much work did I get done? I got no work done because the object did not move. We determined the definition for work to be work equals force times distance. I love it. Sometimes you ask somebody, how much did you work that day? Think of how much distance you put in. I mean, that's good. I like that. I like that right there. And we need force as well, okay? These are important elements to talk about in mathematics and in physics. I'll give you one example. But we want to calculate work being done, no problem. We need a force vector, so work is equal to force times distance. I have a force vector. The force vector is I plus j, which is just 1, 1. That's my force vector. Now, I need a distance vector. The distance vector has a horizontal component. It has a vertical component. What is the horizontal distance moved here in this situation for P to Q? I moved 3 units positive. If I move 0 to 4, I moved 4 units positive. Agreed? So if you want to calculate the work being done, so the vector 1, 1, that would be, moving it, say, like at a 45-degree angle. So say over 1, up 1. So you're pushing something like that, and it moves 3 units horizontally and 4 units vertically. You get 3 plus 4 is 7 units of work done. 7 units of work done. Go ahead and see if you can calculate the amount of work done in the second one. Yep. I have negative 1 units of work being accomplished. Everybody okay with that? Okay, who at their house mows the lawn? I mow the lawn. You mow the lawn. You do. You do. You do. You guys, there more people mow the lawn in this class than like the previous 2 classes combined. Like they're like, heck no, my mom does that. I have both and 4 chainsaws. Yeah, I want to know the story about the lawnmower. Ooh, wow. That would have been good to see on like TikTok. I would watch TikTok if that was on there. You ran over a frog with a lawnmower? That's disgusting. All right, here we go. There's Borisma. She's out mowing the lawn. Should we give her some hair? Borisma. Here. That's gasoline. They put up too much oil in the tank. 2-cycle engine, too much gas, too much oil. Burning. Starting to stink. This isn't like a fast. We're not going out to like get a suntan. We're going out to get some serious work done because you can see that we've cut the grass real nice here because it was super long. I mean, it was like inches above the lawnmower. Okay, Aaron was getting complaints from the city saying, hey, that's a bad grass. You get that taken care of. And so, yep, so Erin's coming on in, and she's going to mow this lawn, and she mows 80 feet. And she's sitting there thinking to herself, I wonder how much work I've done if I have, 80 feet lawnmower, and I'm like pressing down on the handle and pushing at 60 pounds of force. That's kind of heavy duty lawnmower, isn't it? Because maybe hers doesn't have an engine that actually works. Maybe she's got like just right. And the grass is super long, so it's tough to get through. So 60 pounds of force, that's pretty significant. But you got to do that, okay? And it says that it forms a 35-degree angle with the ground. And so we want to calculate the amount of work done. Sounds impossible, doesn't it? It's not impossible. We know exactly that work is equal to your force times your distance. So all I need is two things. I need a distance vector, and I need a force vector. Let's do the easy one first. Distance vector. How far is this being displaced horizontally? 80. How far is it being displaced vertically? None. Distance vector. Done. Force vector, we got to come back here to where we're applying the force. We have a horizontal component to force, and we have a vertical component to force. So, look at this part right here. This is the horizontal portion of your force vector. How do we come up with the horizontal component of a vector? Good. Or the magnitude of the vector, which is 60, multiplied by the cosine of the angle. Remember that? Set those up the other day. And the vertical component is the same thing. It's just 60 times the sine of 35. Horizontal component, vertical component. Done. I take out my calculator. I'm going to let you answer that on your own. 60 times the cosine of 35. And I get 49.15. And I have 60 times the sine of 35. And I have 34.41. I've got my distance vector. I've got my force vector. Multiplying together. 80 times 49.15, 34.41. 80 times 49.15 is 3,932. And 0 times 34.41 is 0. So it's 3,932. And what is the label? The label is our measurement in distance, which is feet, times, because we're multiplying, and the force is pounds. So foot-pounds. Foot-pounds is the label. Yes. Tomorrow we have a couple of word problems to do that are a little bit more challenging. And that will end our unit. As I stop the video, I have to